So welcome students, today we will discuss about the electrodialysis. So electrodialysis is a membrane based process, water purification process where we remove the salts from membrane. In this process membrane used are charged membrane, so that membranes has the charge on that, and we use the electrical potential as a driving force for separation. So there are two different types of membrane used in the electrodialysis. First is called the anion exchange membrane, or in short AEM. In AEM the membranes are the positive charged, and these membranes allows only the negative charged ions to pass through it. Second are the cation exchange membrane, which are called the CEM. These membranes are negatively charged, and these membranes allowed only the positive charge to pass through it. So basically this type of electrodialysis process is used where you have the salt as a impurity in the water. So you can separate out the salt from the water by using the electrodialysis. So for example, you want to purify the brine. Brine is the concentrated salt solution from by using the electrodialysis. So this is the diagram. Okay, so in this diagram this is the small setup of electrodialysis layout of the electrodialysis process for purification of water. Suppose you have the brine, which is the concentrated salt solution like seawater. So you want to separate it out. So you can fill the brine in the different chamber. You have the pairs of anion exchange membrane and the cation exchange membrane, which are situated in between a pair of cathode and anode. So this is the cathode. So cathode is the electrode which is negatively charged and which collects the positive ions, and this is the anode. Anode is the positive charged electrode, and it collects the negative ions. So in between you have the pairs of membrane. You have to carefully situate the membrane in this way that it will come like AEM, that is the anion exchange membrane, then CEM, that is the cation exchange membrane, then again AEM, which is the anion exchange membrane, then again CEM, which is the cation exchange membrane. Now you have to fill these chambers with the NaCl solution. So when you apply the chemical electrical potential across the system, then here you have the NaCl salt, which will produce the Na positive ion and Cl negative ion. So Na positive ion will move towards this cathode, and Cl negative ion will move towards this anode. AEM, this AEM exchange membrane, anion exchange membrane. So this is the positive charge membrane. So it will allow the anions, Cl negative ions, to pass through it, and the Na positive ions will collected near to this cathode. Now in this chamber, here also you have Na positive ion and Cl negative ion. So Na positive ion will try to move, because here you have the negative charge, here you have the positive charge electrode. So you are applying the chemical potential in this direction. So the positive ion will try to move towards the cathode, but this AEM ion will not this AEM membrane will not allow to pass the positive ion through it. So it will remain in this chamber. Similarly, the negative ion try to move towards the anode, but this CEM, cathode exchange membrane, will not allow to pass the negative ion from this membrane from through it. So it will again, negative ions will remain inside this chamber. Now in the middle chamber you have the positive ion. Again you have the Na positive ion, Cl negative ion. So Na positive ion will move through the cathode, and here you have the cathode exchange membrane. So positive ion, Na positive ion, will move across the membrane and it will comes through this chamber, and similarly the Cl negative ion will move from the anode exchange membrane and it will come through in this chamber. So here you have the from here the Cl negative ion will come, from here the Na positive ion will come. So here again you have the neutral charge and you have the higher concentration of NaCl, and from here the NaCl ion, the Cl positive and Na positive and Cl negative ion will move the two other opposite directions. So here you have the here you have the dilute concentration of NaCl. So similarly here again the Na positive ion will move at the towards the cathode, and Cl negative ion will move towards the anode. But here you have the anode anion action membrane, and here you have the cation action membrane. So ions cannot be moved, and again you have the concentrated NaCl solution, and at the anode the Na positive ion will move towards the cathode action membrane, and Cl negative ion will move towards the anode. So again you have the again you have the concentrated NaCl solution in this chamber. So what will happen to this positive ion, Na positive ion? Na positive ion will give the positive charge to the cathode, and then it will mix with water and create the NaOH caustic soda. Similarly here the Cl negative ion will move towards anode, and it will give the charge, and it will make either the HCl solution or Cl2 gas. So here you have the NaOH solution, here you have the HCl solution or Cl2 gas, and here you will get the concentrated NaCl solution. Here you get the concentrated NaCl solution, and in the middle chamber you will get the pure water. So in this way you can separate out the solution using the electrodialysis process. Now the basic application of electrodialysis process. So basic applications are production of potable water or desalination. Especially this process is used to separate out the seawater. So especially in the ships where when the concentration of salts are very high, then the reverse osmosis is not economical. At that time you can use the electrodialysis process. So especially this process is used to separate out the salt from the seawater. The other production of potable water from the seawater, especially in the ships. And the second use is to treatment of wastewater stream if that has a lot of salts. That removal of salts and acids from the pharmaceutical solution. This is also the electrolysis process is a lot of use in the pharmaceutical industry, where you want to remove a specific type of salts and acids from the pharmaceutical solutions. And also it can also be used in the food processing industry. Especially it is used to remove the tartaric acid from the wine, which create a special type of taste in the wine. So this tartaric acid need to be removed from the wine. So this process, electrodialysis, is used to purify the wine. Then the production of salt also, because here you will get the concentrated solutions, so that concentrated solution can be used to production of salt. It is also used for water splitting using the bipolar membrane. So I will explain you what is the bipolar membrane. It is also used to production of caustic soda by using the membrane based process. So now we will discuss about the bipolar membrane. So basically in bipolar membrane you have the two different charge at the opposite face of the membrane. So one face is the cathode action membrane, and the other face is one is the anion action membrane, and the other is the cation action membrane. So here you have the negative charge, so it is a cation action membrane. Here you have the positive charge, so it is a anion action membrane. So when the different faces of membrane has the different type of charge, that is called the bipolar membrane. So this membrane is generally made in one step. You cannot combine the both membranes. You just not create the bipolar membrane by combining combining the one anion action membrane and cation action membrane together, because it will the chemical potential, the requirement of chemical potential in this case is much higher. So generally we make a membrane, we polymerize the polymer in this way. Both membranes has both face of the membrane has the different type of charges. Now we will see how to produce NaOH and H2SO4 by using the bipolar membrane. So here you have a setup where you have the cathode, which has the negative charge and collect the positive ion. Then you have the anode electrode where you have the positive charge and it will collect the negative ion. Then you have the combination of membranes. So here this is the cation action membrane, which will allow to pass the positive ions. Then the anion action membrane, which is allowed to pass the negative ions. Then you have the bipolar membrane, which has the different charges at different phases. Then here you have the C, again the cation action membrane. Then here you have the again anion action membrane. Now in the different chambers are filled with the solution of Na2SO4 salt. So when you use the Na2SO4 salt in the different chamber, so here in the middle chamber the Na positive ion will move, because this is the cathode. It will collect the positive charge. So the Na positive ion will move in this chamber. Na positive ion will move in this direction, and CO4 negative ion will move in this direction. So when Na positive ion will move in this direction, here you have the cation exchange membrane. So it will allow the Na positive ion to pass through it. So you will get the Na positive ion will collect here. Similarly, the SO4 negative ion will move in this direction. Here you have the cation exchange membrane, so it will allow to SO4 ion to move the other side, so pass through it. So here you will get the SO4 ion, and this H positive ion which comes from the water, because here you have the bipolar membrane which has the negative charge. So it will allow the, when the water will pass through this membrane, it will allow the H positive ion to comes in this chamber. So this H positive ion will react with SO4 negative ion, and it will create the H2SO4. Similarly, here the Na positive ion from this chamber, Na positive ion will comes here by using from this cation action membrane. It will allow to pass the positive ions from it, and SO4 ion will go here. So it will across the anion action membrane. Here Na positive ion will react with OH negative which present in the water and create the NaOH solution. So here you have the acid H2SO4. Here in this chamber, from this chamber you will collect the NaOH, which is the base. So and SO4 will comes here. So here again you will get the acid H2SO4 from this chamber, and here again you will get the, because the Na positive ion will again react the OH present in the water. Here again you will get the NaOH solution. So in this way you will get the H2SO4 and NaOH solution from the Na2SO4 salt. Now this is the simple diagram to produce the caustic soda from the salt. So here you have a cation exchange membrane by using the single membrane. This is the anode which will collect the negative ions and has the positive charge. This is the cathode. This is the anode. This is the cathode which will collect the positive charge and has the negative ion, which will collect the positive charge and has the negative which will collect the positive charge and has the negative ions. So this is the cation exchange membrane. So here you will put the pure water, and here in this chamber you will put the NaCl solution. So from NaCl solution the you will get the NaCl solution salt will decompose as Na positive ion and Cl negative ion. So this is the cation action membrane. So it will allow Na positive ion to pass through it. This is the negative charged electrode. So it will attract the Na positive ion, which will create the driving force for the Na positive ion. So Na positive ion will pass through it. It will comes here. So and Cl negative ion will not pass through it because it will repel. This is the cathode action membrane. It will only allow the Na positive ion to pass through it. So this Na positive ion will react with OH negative ion and create the NaOH solution. Now this Cl ion will give the electron to this electrode. This is the anode. It will collect the negative ions. So this Cl negative ion will give the electron to this electrode, and it will create the Cl2 gas. So you will get the Cl2 gas and the NaOH solution by using this setup. Now if you want to split the water, then you need the high electric potential. So if you use the high electric potential, then water will split as positive H positive ion and OH negative ions. Now the cathode action membranes are also called the cation action membranes are also called the proton exchange membrane. Why? Because it will also exchange the H positive ions. So type of these are the types of different types of proton exchange membranes which can be used in this process. Now ion exchange membrane properties or requirement. So ion exchange membrane should have the higher selectivity for opposite charge ion and high permeability. Second, low electrical resistance. Third means higher conductivity, and third is high mechanical strength and stability. So basically, if you are using the cation exchange membrane, so it should be highly conductive for the cations, but it should have the high resistance towards the anions. So it should only allow the protons to pass through it, or the cations to pass through it, but it should also resist the anions. It should also resist the negative charged ions or electrons. If you are making a membrane, or just the it is very conductive but it is not selective towards a special ion, so it is not a ion exchange membrane, because it is only pass the all different type of ions through it, but it will not selective towards a specific type of ions. So it should have the higher selectivity for the opposite charged ion, and it should have the higher permeability also. If suppose you want to pass the Na positive ion, to ion has a large size, so it should be highly permeable also, and it should have the higher mechanical strength and stability. Stability means the physical stability as well as the chemical stability. It should not be react with the solution, different type of solution, salt or acids. So these are the requirement of ion exchange membranes. Now the type of ion exchange membrane. There are two different types of ion exchange membranes. First is the heterogeneous membrane, and second is the homogeneous membrane. So basically heterogeneous membranes are the membranes where you have a polymer matrix, and you just mix the ion exchange material or conducting material, or the any positive charge or negative charge material in it. So this can be made by the three different methods. First is the dry film casting. In dry film casting, you take a powder of the polymer and take the powder of the ion exchange material and just mix the powder, and just go for the compression and the sintering process. So you can make the inorganic ion exchange membrane by using this process easily. So this process are generally used when you make the inorganic ion exchange membrane. Then second process is the basically you have the polymer solution. You make a polymer. This is also a type of phase inversion method. You have the polymer solution, you mix the ion exchange powder in it, and then cast a film and evaporate the polymer solution. This is a phase inversion method to create a ion exchange membrane. Third is the polymerization method, where you partially polymerize the film first, then you mix mix the ion exchange powder on it, or spread the ion exchange powder on it, then you completely polymerize the film. So the ion exchange powder will mix in the matrix of the partially polymerized film and create a ion exchange membrane. These three are the procedure to create the heterogeneous membrane. Now there are some procedure to create the homogeneous membranes. So in the homogeneous membrane, you just there are two different methods. So in first method, a reactant of this membrane is created during the polymerization, and a reactant of polymerization contain the ion moiety or the charged group, which will give the anionic or cationic property to the membrane. So there are different type of moieties which can be used to give the anionic or cationic property. So these are the moieties or the ionic groups which will use to give the cationic exchange membrane to create the cation exchange membrane, or these are the moieties or groups which are used to prepare the anion exchange membrane. And second method to create the homogeneous membranes are the grafting method. In this method, first you create a membrane just a porous film, then you can use the grafting method or grafting polymerization to stick to react the different ionic groups to the surface of the pores as well as surface of the film or the surface of the pores. So then the all the surface of that film will have the different type of ions. So these two are the methods to create the homogeneous ion exchange membranes. Now the transport phenomena of electrodialysis. So basically electrodialysis is generally represented by the nearest Planck equation, Nernst-Planck equation. In Nernst-Planck equation, basically we equivalent the chemical potential of membrane phase and chemical potential of the solution phase. So this is the formula for chemical potential for membrane phase, and this is the formula for chemical potential for membrane, and this is the formula for chemical potential for solution. So here this part represent the chemical potential due to the concentration difference, and this part represent the chemical potential due to the electrical potential or electrical driving force. So you need not to remember this formula, this is just for your knowledge. Now this is the Nernst-Planck equation which is used to calculate the flux. So this is the diffusion part which comes from the Fick's law, and this is the electrical this is the flux due to the electrical potential, this is the flux due to the concentration difference, and this is the flux due to the electrical potential. So here this term will come from this equation. Now you have to remember about the transport number. It is a very important parameter to identify the characteristic or quality of the membrane and ion exchange membranes. So any ion exchange membrane, the characteristic of the ion exchange membrane or the quality of the ion exchange membrane can be defined in terms of transport number. So transport number should be equal to current carried out by the particular ion divided by the total current. So suppose you have an ion exchange membrane. So in an ion exchange membrane only allows to pass an ion through it. So suppose you have a setup like this. This is the cation exchange membrane. So it allows to the positive ion to pass through it. Suppose here you measure the current, how much current is passing through the electrode, total current is passing through the electrode, that is the one quantity, and how much current is passing through this Na positive ion. So the ratio of that, see how much current is passing through this Na positive ion divided by the total current, that is called the transport number. It signifies that what is the quality of the membrane. It should be 1. That means that current should be only passed due to this Na positive ion. If it is less than 1, that means some of the anions are also passing through this membrane. So membrane should be very high selective. So that means if you have an ideal membrane, it will not allow any anion to pass through it. That means all the current all the current flowing in this setup is due to only the cations, and that means you have the transport number 1. So transport number signifies the quality of the membrane. That's why it is a very important parameter. So this is the formula of transport number, that is equal to current carried out by a particular ion divided by the total current. So for AEM means an ion exchange membrane, the T positive transport number for positive ion should be 0, transport number for negative ion should be 1 for in the ideal case, and for cation exchange membrane the transport number for the positive ion should be 1 and transport number for negative ion should be 0. These are the ideal case. But in the real case, the most commercial membrane, not the laboratory made membrane, but most commercial membrane has the for AEM membrane, ion exchange membrane, you have the T positive 0.04 and T negative 0.94. Generally membranes are 94% selective. Similarly, for cation exchange membrane, T positive are 0.95 and T negative 0.05. So these are for the real commercially available membrane. Suppose you are making the membrane in laboratory, then you have to compare, you have to calculate the transport number, which will signifies your property of membrane. As I told you that membrane might be very much conductive, but it might not be the ion exchange membrane. Ion exchange membrane should be selective for a particular ion. It should not be it cannot be the it cannot allow to pass the both type of ions through it. So it should be selective. So this is the very big difference between the simple conducting membranes or membranes. Ion exchange membrane, ion exchange membrane should be very selective towards a particular type of ion. So this is all about the electrodialysis.